Chapter 25, Problem number 19. The image produced by a concave mirror is located 26 centimeters in front of the mirror. The focal length of the mirror is 12 centimeters. How far in front of the mirror is the object located? So the equation that I used in this problem is this one right here. 1 divided by the distance of the object plus 1 divided by the distance of the image is equal to 1 divided by the length of the focal length. We are looking for the distance of the object because the question was how far in front of the mirror is the object located. So I just did a little algebraic manipulation to get this equation right here. I subtracted the distance of the image and I put it on the right side of the equation. And before I start plugging in values, I noticed that the values were in centimeters and not in meters, and I just always feel like it's a good idea to convert these values. So I know 26 centimeters is equal to 0.26 meters, and that was the distance of the image, and 12 centimeters is also equal to 0.12 meters, and that is the distance of the focal length. Now, after this, all I have to do is plug in my values to this equation right here. So we are looking for the distance of the object, and so it will be 1 divided by 0.12 meters, the distance of the focal length, minus 1 divided by the distance of the image, or 0.26 meters. If I do that, then I get 1 over the distance of the image is equal to 4.48 meters. However, this is 1 divided by the distance of the image, and it is not the value of the distance of the image itself. Therefore, I took the reciprocal of this right here in order to get the distance of the image, and I found that to be a value of 0.22 meters. Or, if you wanted to rewrite it like the values originally given in the equation, or the problem, that would be 22 centimeters. Now, in order to do a little recap, I just used this equation that was given to me in the problems at the back of the book. I rewrote it because we were looking for the distance of the object, and I did that by subtracting the distance of the image, and I put that on the right side of the equation. Therefore, from this equation right here, all I would have to do is just plug in. I noticed that the values were given in centimeters, and I wanted to convert that into meters. And then I went from here to here, and I just plugged in the values that I got here. So that was 1 divided by 0.12 meters, subtracted by 1 divided by 0.26 meters. And that gave me the value of 1 divided by the distance of the image. And that's not what we want. We want the distance of the image. Therefore, we had to take the reciprocal of this. And I ended up getting 0.22 meters as my final answer. Or, if I converted it back to centimeters, that is 22 centimeters. And this right here is the final answer for the problem.